this is a little better spot. When you look at number 3, I'm wondering, and I don't know if we'll know this or not, but I'm wondering if you could look at number 3 and maybe mentally do a term or two of the series, just kind of think about what the terms would be, see a pattern, I don't know. Is there any chance that at this point you could look at number 3 and say, oh, I recognize that that's really something significant that you've looked at in your past, something that we've looked at in this class, but I haven't really expected you yet to have this memorized. Anything jump out to you? Cosine or sine, yup. He's right. Which one would you take a shot on here? Come on, think. You could have a good reason for your answer. Yes, there it is. Did you notice that all of the exponents and all the factorials would be odd, wouldn't they? 1, 3, 5, 7, 9. Sine is an odd function. This actually ends up being sine. So the radius of convergence of sine, sort of proved this to you at the start of this chapter, that it could converge potentially for all real numbers. And so this radius should be infinity. Let's prove it, okay? This will be a good review from last time. So, do you guys remember what test we used to show radius of convergence? Ratio? Yeah, ratio test, that's right. So I'm going to set this up as the limit, as n goes to infinity, of, because of the absolute values, I can essentially ignore the alternating part. So I just won't include that on anything here. The absolute values will make that a non-factor. So I'm going to put the n plus 1 term in first. So it's going to be x to the 2 parentheses n plus 1 over 2 times n plus 1 factorial. Now, I would hope that maybe in the course of a quiz or a test, you would distribute the 2 and add the 1 and come up with 2n plus 3. But I wanted to show you that we're plugging that n plus 1 in for all the n's. And then I'm going to automatically copy dot flop. So I'm going to copy the first one, multiply times the flop of the denominator. So that would be 2n plus 1 factorial over x to the 2n plus 1. Keep in mind that we're looking for convergence here, so we want the ratio test to give us what sort of number? Less than 1. So I'm going to just go ahead and put less than 1, and we'll see how this all works out. We've got to do all of our algebra jumping jacks and figure out how this works out. You guys see with the x's, I essentially have x to the 2n plus 3 over x to the 2n plus 1. What do you do with these exponents if you are dividing your bases? You subtract. If you are dividing bases, and I'm talking about this right here and this right here. If you are dividing bases, then you subtract your exponents. So the x would end up having an exponent of what? 2. That's right. So limit as n goes to infinity, it would be x squared right here. Okay, and then with the factorials, you've got 2n plus 1 factorial over 2n plus 3 factorial. Are you guys to the place where you can see this? Can you see the cancellation and what's going to be left over? What do you think is going to be left over?
2n plus 3 plus 2n plus 2.
If you put times in there, then I agree with you. 2n plus 3 times 2n plus 2 is right. Would you guys like to see that done? Be happy to do it. Why don't I show it to you? I'll show it to you one more time. So if we're going to do this cancellation, it would be limit as n goes to infinity, and then I would just kind of write out my factorials. So it would be 2n plus 1 factorial would be, now you know, I'll do the denominator first. 2n plus 3 factorial would be 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. And then 2n plus 1 factorial I'll just leave as is. So you just see how this would cancel with that, leaving us with what Grace had outlined earlier. So we've done this a lot, but again, there's a lot going on, so I want to make sure that you're solid. Do you have any questions there? This will lead us directly, really, to our answer. So what's left over here is essentially limit as n goes to infinity, and it's x squared over 2n plus 3, 2n plus 2, and that's supposed to be less than 1. Remember, the limit specifically applies to n. So in our fraction, the denominator is getting gigantic, right? So the truth is, it really doesn't matter what the numerator is. It's going to be some real number. If it's over something approaching infinity, the overall value of the fraction, again, is approaching 0. So I think we could write this whole limit as 0 is less than 1. And so since 0 is less than 1, then that really means that the radius of convergence does not depend on the x value at all. It means that any x value would work because all the x's basically got infinityed out, if you will. And so since the radius of convergence does not depend on what the x is, that means that any x would work. And so if you wanted to think about this like an interval, you could say, well, it's negative infinity is less than x, which is less than infinity. That's another way of saying that your radius of convergence is infinity. Any x value would work. There isn't one that wouldn't work, and so your radius is infinite. It won't always be this way. I know the first two have been like this, but it won't always be this way. Okay, so the first one we did was cosine. This was, right? This was sine. So we'll keep building this up, and I think by the time we finish today, we'll be looking at kind of a list of things that we want to make sure that you guys have a really good handle on. Any questions before we move on? We'll keep practicing this. Don't worry. We're not going to just leave this alone right now. No questions?
So what's the conclusion? Like, how do you draw since it's less than 1?
So maybe it'll be a good comparison when we do our next one. So when we look at an interval of convergence or a radius of convergence at this point, we're basically asking ourselves, over the course of what set of numbers for x will work here? Will we get a convergence? And so if it's possible that we could get a situation where this will not, like the limit won't cause that to go to 0, it could be like 5x or something like that, and now there's going to be kind of a really set domain of x values that will work and everything else won't. So you'll see that, I think, on the next one. It's a good question. Anyone else with a question? All right. Oh yeah, Jasper, go ahead. So r is the radius of convergence. So at the very start it said find the radius of convergence. So what I'm saying here again is that since we got like a mathematical conclusion of 0 is less than 1, what that tells us is that the radius of convergence does not depend on x at all. And so that means that any x value could work, and so the radius is infinitely large, right? If you think about, let me ask you this. For this series right here, do you guys know what the centering point is? 0, right? Centering point is 0. That's exactly right. It's Maclaurin series for sine. And so if the centering point is 0, it's saying, the question is asking basically from 0, how far to the right or left can you go before you start to get numbers for x that don't work, right? And the truth is, if you start at 0 and you go all the way over towards positive infinity, or all the way over towards negative infinity, all of the x values would work. All of them would work. And so the radius with which you could create this interval is infinite. But Jasper, I think, kind of along the lines of Jared's question, I think when you see the next example, you'll see a good contrast to where you can be like, oh, okay, we only saw it one way. Now we're seeing it a different way. You can see where that x will come into play and create like a actual finite radius of convergence. Is that okay? Maybe trust me on this one, and maybe we can go back and kind of compare in just a second. Okay, so I want to go, so we're going to skip number 2 for the moment. We might come back to that one a little bit later, but I thought we'd go to this one right here. Yeah. Okay, so finding the radius of convergence is going to be a step along the way in this one. There will be a little additional step that's tagged on to the end of this, and it's one of the reasons that we have done all of our convergence tests and gotten hopefully good at our convergence tests. It's going to be how we finish this one. So notice number 4 does not say find the radius of convergence. It says find the interval of convergence. So let's look at how this is going to go. We're still going to use the ratio test. Still how we're going to start off. So our series is x to the n over n. So here we go. Let's go limit as n goes to infinity. And that's going to be the n plus 1th term over n plus 1 times n over x to the n. So I'm just doing copy dot flop automatically. If you want to set it up as a fraction, I got no problem with that, of course. And as before, we're looking for convergence, and so I'm going to say I want my ratio test to give me something that's less than 1. So far, so good. Just kind of a standard setup there. Okay. Some canceling here. something does cancel, what is it? Yeah, the x to the n's cancel, so that leaves you with limit as n goes to infinity, and it would just be x, and I'm going to rearrange it just a little bit. I'm going to write it as n over n plus 1. Is that okay? Just kind of move the denominator over there, the x. I did my x cancellations, I got x to the first.
Wouldn't x still be over n plus 1?
Oh, it is.
It's multiplication.
X over 1 times n over n plus 1. I could like multiply it back together, but the reason why I'm separating it out is that the limit only applies to n, and so I wanted to get all the n's kind of grouped together appropriately, and I'm going to leave the x kind of off to the side for the moment. That's just to hopefully keep things as clear as possible, but if you wanted to, you could multiply it back together. So with that in mind, if the limit really only applies to the n's, we can kind of ignore the x for the moment. What is the limit as n goes to infinity of n over n plus 1? So you could do L'Hopital's rule, or you could do the whole degree trick that you learn in pre-calc. You end up getting 1. So in the end, this would be absolute value of x times 1, or of course you could just write x. So absolute value of x is less than 1. So here is where we go a little bit, I think, Algebra 1, old school on you. Do you guys remember how to solve an equation like this? Or this, sorry, inequality like this? Say again? No? Because it's absolute value of x, right? So it's saying that the distance from 0 on the number line needs to be less than 1. So yeah, so here's actually how you do this, and you guys have identified the right interval. What you do is you create two cases, one of which where you simply drop the absolute values, and the other one you drop the absolute values, flip the inequality, and change the sign. Remember doing this in Algebra 1? Algebra 2 maybe, it's been maybe a while, but this is the way that you deal with this inequality. And so you guys identified it pretty well. You definitely want to be able to do that though. Things can get a little bit more complicated at times, so you want to be able to do that. So if we're supposed to be, if x is supposed to be bigger than -1 and less than 1, that's where you get something like this. -1 is less than x, which is less than 1. Okay, so this is my provisional answer. And I say provisional in that I know for sure that my centering value is 0. Can you tell from this that the centering point is 0? If it was something other than 0, what would be there?
X plus something.
Yeah, x plus 2 or x minus 5. That would tell you your centering value would be like -2 or +5. But it's just x, right? So you know it's going to be centered at 0. So do you see the centering at 0 in our interval of convergence? Do you see how 0 is right in the middle of that? Those two things should agree, right? If they disagree, then there's something that's wrong. They should definitely agree with each other. So here's the final question. I said provisional answer because that means we're not quite done yet. We need to check to see what's happening at the endpoints. In other words, does the convergence go right up to the endpoints but not include the endpoint, or does it include the endpoint? In other words, is it going to be a filled-in circle or an open circle? Right? Because we're creating this interval of convergence, and it could be an open, or it could be closed, it could be a mix between the two. Here's how we do it. We're going to go back and reference this to help us decide, and we'll come up with a final answer. So here's how I usually note this. I'm going to say for my left endpoint, so that would be for x equals -1. If x is -1, then my series would become this. Sigma from 1 to infinity of -1 to the n over n. Now here's where we're supposed to be really smart with our convergence stuff. What kind of a series is that? It's alternating harmonic, right? It's an alternating harmonic. What do those do? They always converge. So here's how you note this. You just say this converges, and the only reason you got to give is just to write something like alt harm, alternating harmonic. You've identified it as an alternating harmonic. You know that they always converge, and so you say converges. This is where all that work put into those sorts of things in your background as your foundation will make stuff like this to conclude pretty easy. Hopefully that'll be the case for everybody. So I got a convergence at my left endpoint, but we got to test out the right endpoint too. So I'm going to put for x equals 1, my sigma would be this, and it would be 1 to the n over n. What does that do? Because Yes, well said. So this diverges, and the only reason you got to really give is that it is a harmonic series. And we know from our past, based on p-tests and integral tests and whatever else, we know that those always diverge. So this was my provisional answer down here. My actual final answer would be this. -1 is less than or equal to x, which is less than 1, based on my analysis of the endpoints above, and now I'm done. So this is one of those hybrids, right? The left end is closed, the right end is open. Sometimes they're both open, sometimes they're both closed. I mean, you never know. You got to actually test it out. So, what do you guys think? Do you have any questions? Go ahead, Grace.
Why is alternating harmonic converged?
Because it's an alternating series, and the terms decrease in absolute value to 0. I'll try to squeeze this. Sorry?
How is that a harmonic, and why don't we just say because it's alternating and the values decrease in absolute values?
You could. I think it's easier to say it's alternating harmonic. Done.
Is that just the same thing?
Well, so it's a special case of an alternating series. And so if you want to say what you said, where you say, hey, this converges, and my reasoning is the alternating series test, because, and here's what all you'd have to say. You'd have to say it's an alternating series, the terms decrease in value, and then throw in the limit as n goes to infinity equals 0, right? So the terms decrease in value, absolute value 0. Therefore, by the alternating series test, this series converges. You can write all that, and that's totally okay. I just feel like it's easier to just go, it's an alternating harmonic, period. Does that make sense? So you can use either one of those. I got no problem with it. I'm just trying to lead you guys to the fastest way.
Okay.
Yeah.
So if the x equals 1 had been converging, would the only thing it would change be that you would have an equals, like a...
Yep. If that were the case, then this guy would show up here. Yep. And so because you got a convergence here, that's why this appeared.
Okay.
So sometimes you'll see me do this. I'll put little question marks over these, and I'm just questioning the open or closed nature. Let's say it's a provisional answer. I know that that's my radius is 1, my center point is 0, but I don't know the endpoint behavior yet. So I'm going to test things out there and see if I close either or both of the intervals.
Okay.
Anyone else? Great questions?
Can you just quickly run over the absolute value thing again? What do you do?
Oh, so any absolute, yeah, anytime, and can I just do a totally different one just for kicks? So I'll just go over here. So just some random question like that. Like let's say that we've got, I don't know, absolute, I'll make it a little more complicated too. How about that? So let's go, absolute value of 3x minus 5 is less than 1. So here's what you do. Whenever you've got an absolute value inequality, I can explain the reasoning behind this. I could show you a little graph, but here's like what you do. Here's the nuts and bolts. You create two cases. The first case is one where you simply drop the absolute values altogether. This is the positive case. And then the negative case would be this. Drop the absolute values, flip the inequality, change the sign on that number that it's relating to.
Okay, so it would be 3x minus 5 in total.
Oh, doggone it. Why did I put plus 5? I was trying to clear this up for you, and I don't know why I did that. 3x minus 5 is greater than negative 1. So, yeah, when you drop the absolute values, you just leave that expression on the inside totally the same. And then from there, you just solve each inequality. So here, you'd get 3x is less than 6, x is less than 2, 3x is greater than 4, x is greater than 4/3. So your interval would go from 4/3 to 2. And then if this were one of these problems, then you check the endpoints and decide are they closed or open or a mix. We'll practice this some more, don't worry. Any others? Okay, awesome. So let's see here. What is coming up next? We got one more kind of like that. So find the interval of convergence for that right there. Now I want you to notice something right away. This series is different a little bit. The centering point is at 0. What is it? It's technically negative 1, right? Because remember with that Taylor construction, it's x minus c. You see the x plus 1 in there? So the x plus 1 is not just an x. If it were just an x, then we would say, yeah, it's centered at 0. But it's x plus 1, so that means your centering point is not 0. it's x minus c. So it's not x minus 0, it's x minus negative 1. It's not terribly important at this point, but I just thought I'd mention it. Okay, so we're going to try to find the interval of convergence. What do we use? Ratio test. So this is going to be the limit as n goes to infinity of the absolute value. Again, we're going to totally ignore the alternating element because of the absolute value. It's not going to have any impact whatsoever. So it's going to be x plus 1. X plus 1 to the n plus 1 over 2 to the n plus 1 times 2 to the n over x plus 1 to the n. Hoping that this ratio test is feeling pretty familiar now, right? I hope it is. Is that the case? Okay. So now, no factorials, kind of like the other one, nothing like that to deal with, but we definitely have some cancellations. Can anyone do those? And we can discuss how we got to those, but can anybody let us know what you think the resulting expression would be?
X plus 1 over 2.
What do you guys think? X plus 1 over 2. So basically anything having to do with an n canceled out, didn't it? So what do you think this means, right? X plus 1 over 2, there's no n's. What do we do with that limit? The limit doesn't matter. So you can do the limit as n goes to infinity, but it's not going to change the expression at all. So what we can do is, like, as we execute the limit, doesn't it just drop off? And so my next step would just be to write, okay, fine. It's x plus 1, and I think what I would do here is say that the absolute value of 2 is 2. And if that's okay to do that in the same step, still less than 1. So this one's kind of weird because the n's just ended up not being really a factor when it came time to do the limit. All right, so we're still trying to find our interval of convergence. What I would do here, I think, is multiply by 2, get rid of the fractions. So absolute value of x plus 1 is less than 2. And here, Allie, will you give us a shot here as far as how we break this thing down?
Oh, absolutely. X plus 1 is less than 2, and then x plus 1 is greater than negative 2.
That's exactly right. Perfect. So then we take those two inequalities and we solve them. So for you guys, obviously a very easy solve. X is less than 1. X is greater than negative 3. So if you think about it, if we're supposed to be thinking about x's that are bigger than negative 3 and at the same time less than 1, aren't we talking about this? So again, once again, that's just a provisional answer. We don't know the endpoint behavior yet, so I'm going to put little question marks here signifying that I'm not really sure about, do I know if it's open or closed? We just need to test the open or closedness of this. This one's a little trickier. This will take a little bit of thought as far as open and closed. So let's get into it. For the first one, we're going to say for x equals negative 3, here's our series. It would be sigma from 0 to infinity of negative 1 to the n, and then negative 3 is x, so negative 3 plus 1 is negative 2. So that would be negative 2 to the n over 2 to the n. Huh, that's a little weird, isn't it? Could we do a little separating out to see what happens? So that negative 2 to the n, we could rewrite this as sigma, and it would be negative 1 to the n times negative 1 to the n times 2 to the n, all over 2 to the n. Because isn't negative 2 in parentheses to the n, that n exponent would apply to both the negative 1 and the 2. See what I've done there just to expand it out? So a bunch of stuff happens here, like this cancels with this. And what's negative 1 to the n? Isn't it just negative 1 to the 2n if you add your exponents? This is getting really weird. So if it's negative 1 to the 2n, doesn't 2n guarantee an even number, regardless of what n is? So it's going to be negative 1 to some even number. So we're going to get convergence or divergence. Let's think about what this, if you're having a hard time, let's think about what the terms would be. Let's do a couple of partial sums. When n is 0, what would you get?
It's always gonna be -1.
When n is 0, wouldn't you get essentially 1 times 1? 1, okay. So when n is 1, what would you get? Bless you. Wouldn't you get 1 again? When n is 2, wouldn't you get 1? And then when n is 3, 4, 5, 6, 7, 8, every single time you do it, you're just going to get 1s. So there we go. So diverges, and it's the nth term test. Okay, what do you think? Diverging because of the nth term test. So that left endpoint, it's going to be left open. It's not going to include that left endpoint. So for x equals 1, you can maybe do this a little bit easier based on the analysis we just did. This would be sigma of -1 to the n times 2 to the n, right? All over 2 to the n. So you're going to see the cancellation immediately, right? 2 to the n's cancel out. So we just end up with sigma of -1 to the n. So let's think about these terms. What will they do? When n is 0? And when n is 1? So it isn't just going to go 1 plus -1 plus 1 plus -1 plus 1 plus -1.
Wait, why is it not in the same form as we used for -3?
Because all I'm really doing when I do this is I am referring back to this at the top, and I'm plugging either a -3 in for x like I did before, or a 1 in for x. So this time when I plugged a 1 in for x, I just got 1 plus 1, which is 2. So that's where I got this 2 to the n right here. So what do you think? -1 plus 1, or basically -1 plus 1, -1 plus 1, -1 plus 1, is that going to converge or diverge? Aren't your partial sums going to go like -1, 0, -1, 0, -1, 0, like depending on where you stop, it's either going to be a -1 or a 0 on your partial sums? So that's diverging, because does the nth term go to 0? It does not. The nth term either goes to 1 or -1, depending on where you decide to think about it, right? So it's not going, but the point is, we don't know what it's going to, but it's not going to 0. So diverges again, and the reasoning would be the same, nth term test. So in the end, our provisional answer was our answer. So we could just lose those question marks and say that from -3 to 1, open on both, would be our interval of convergence. Sorry?
That cannot be 0.
Why can what not be 0?
-1 to the end. Limit n goes to infinity.
Oh, well, so the nth, so think about it like this. If I do a quick nth term test, limit as n goes to infinity of -1 to the n. Like that's what you're talking about, right? So equals what? So I encourage you to think about the partial sums. The terms go -1 plus 1, -1 plus 1, -1 plus 1, -1 plus 1. The point is, are the terms heading to 0? Do you see a clear pattern where the terms, like a pattern to 0 would be like 1, 1/2, 1/4, 1/8, 1/16, 1/32, 1/64, like a geometric series like that. The terms are going to 0, right? You see the terms going to 0 here. They're not. The terms are simply not going to 0. It's either going to a 1 or a -1, depending on where you decided to stop and think about it. But it's not going to 0 with the terms. So by the nth term test, we can say that it diverges. Is that okay? Okay, good deal. Let's see here. I am